The problem is suppose the radius of aluminum nuclei is given. Aluminum, its mass number is 27 and its radius is given as 3 femtometer. So the radius of aluminum is 3 femtometer. Then how much will be the radius of copper? Its mass number is 64. So it's a very simple problem. So let us solve it. Okay. So this is your mass number. Okay. So how will solve? It's a very simple problem. We know that there is a relation between radius of nucleus, that is noted by capital R, and that is simply R naught, some constant, into the mass number, and its power is 1/3. So we'll use this formula. So the radius of copper nuclei, its mass number is 64, divided by radius of aluminum, its mass number is 27, will be simply the mass number of copper, that is 64, divided by the mass number of aluminum, and obviously that power will be 1/3. Okay. So it's a very simple mathematics. Yes.
Yes, sir. Yes, sir.
Very simple mathematics. So it's nothing but 4/3. Okay. So since you know that radius, if you bring this the radius of aluminum on the right hand side, you will simply get the radius of copper nucleus will be 3 times, since the radius of aluminum is 3 femtometer, 4/3, that unit will be femtometer. So it will be simply 4 femtometer. Okay. So the radius of copper nuclei will be 4 femtometer. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now, shall I raise?
Yes, sir.
Yes, sir.
Okay. Now, can you write second problem? Second problem is so that the mean momentum of a nucleon, that is noted by small p. So mean momentum of a nucleon, that notation is small p, is varies with mass number, and that mass number is noted by capital A. So you have to show that the mean momentum of a nucleon inside nucleus varies with mass number, that is A, as the variation will be the mean momentum of a nucleon inside the nucleus will be this kind of variation. So mean momentum will be P equals to proportional to A to the power minus 1/3. Is it clear? So that the mean momentum of a nucleon inside the nucleus varies with mass number capital A as P proportional to A to the power minus 1/3. It's a very simple problem. So how will solve this? It's a very simple problem. We know that radius, yes. So radius will be how much? Or not? A to the power 1/3. So that uncertainty in the position of a nucleon inside nucleus will be how much? Delta X will be how much? That will be
2 times R.
2 times R. Very good. Exactly. It will be 2 times R. So now if we substitute this R, it will be 2 times R naught A to the power 1/3. Okay. Now from Heisenberg uncertainty principle, you know that delta X, uncertainty in position into uncertainty in momentum, will be of the order of H cross. H cross is the reduced Planck constant. Okay. So from here you can clearly write that uncertainty in the momentum will be H cross divided by delta x, and delta x simply 2r0 divided into a to the power 1 by 3. Okay. So you can clearly see that uncertainty in the momentum is proportional to a to the power minus 1 by 3. And the uncertainty in the momentum of a nucleon is of the order of mean momentum of a nucleon. So what you can write, P will be same order as uncertainty in the momentum, and that variation will be a to the power minus 1 by 3. So it means P proportional to a to the power.
बोर्ड के बाहर हो रहा है सर.
Sorry?
सर जो
Okay, okay.
वो नहीं
1 minute. I'll write it on the upper side. Yes. So delta P is proportional to a to the power minus 1 by 3. And delta mean momentum of a nucleon will be in same order as uncertainty in momentum. So from these two equations, you can clearly say that mean momentum of a nucleon will be directly proportional to the mass number, and that power not proportional to, it will be a to the power minus 1 by 3. So this kind of variation of mean momentum will be there inside that nucleus. Is it clear?
सर डेल्टा एक्स 2r के इक्वल कैसे हुआ?
Delta x? Yes. So suppose this is your nucleus. Okay. Its size will be how much? Its radius is how much? R. So that nucleon can be anywhere in this, right? So the size of that or radius of the nucleon nucleus is R, and nucleon can be found anywhere inside that nucleus. So maximum uncertainty will be how much? This much. So it will be anywhere. So maximum uncertainty to find that nucleon inside nucleus will be the size, and size is not exactly R. It will be size is basically 2R. That is the diameter. That will be the maximum uncertainty. Is it clear?
Yes sir. Yes.
Okay. Shall I proceed? Next problem? Yes,
Yes,
online?
sir.
Okay.
हेलो सर.
Yes.
सर आपने जो डेल्टा पी का प्रोपोर्शनल लिया ए टू द पावर -1/3 के, तो
Yes.
सर पी का भी ऑर्डर वही सेम क्यों होगा जो डेल्टा पी का है? डेल्टा पी तो स्मॉल हो गया ना पी के
No,
कंपैरेटिव.
no. Actually, you are no. Actually, you are calculating the delta P around that mean momentum. So it will be same order. If you write, I think Atul sir will explain you very nicely in his quantum mechanics class. So if you remember, uncertainty in any physical quantity, let us assume that is delta P, and that will be P square minus this is right. So for any uncertainty in momentum will be the expectation value square, or momentum square is expectation value minus average momentum square. So that uncertainty in momentum will be in same order as this. It will be same order as this. Okay. Please keep in
Yes.
mind, whenever you are calculating any uncertainty, so the same parameter will be in same order. Suppose this is x, so the uncertainty will be in x will be same order as the p x square uncertainty x square value and x mod x square value or average x square value. It will be always true. Okay, and Atul sir will explain you in his quantum mechanics class. Okay.
Yes sir.
Okay. Okay, next problem, you people please try to solve it. Okay, since we have discussed basic properties, today we will discuss few more properties. But let me solve one more problem. Okay, next problem, please write that problem. Given that the nuclear mass of iron is atomic number is 26, mass number is 56. So given that the nuclear mass of iron 2656 is 55.85 U. U means atomic mass unit. Also, okay, so given that the nuclear mass of iron is 55.85 U. Also inside bracket they have given that R naught, value of R naught, and that is 1.2 into 10 to the power minus 15 meter. Okay. So then they have asked first question, find the radius of nucleus. Please write question number A, find the radius of nucleus. Okay. Question B, find the volume of the nucleus. Question C, find the mass density of that nucleus. Shall I proceed?
Excuse me, sir.
Repeat
Yes.
the question.
Sir, repeat the question, please, once again.
Yes, yes. Question number A, find the radius of the nucleus. Question B, find the volume of the nucleus. Question C, find the mass density of that nucleus. Okay. So first two, yes.
तो पूरा क्वेश्चन एक बार स्टार्टिंग से बता दो प्लीज.
Given that the nuclear mass of iron 2656 is 55.85 U. U means in atomic mass unit. Okay. Also, they have given that R naught value, that is 1.2 into 10 to the power minus 15 meter. In question A, part A, they have asked find the radius of nucleus. Nucleus means that Fe 2656. In part B, they have asked volume of that nucleus. You have to find the volume of that nucleus. In part C, they have asked find the mass density of that nucleus. So it's a very simple question. Shall I proceed for solution?
Yes, sir.
Oh, okay. So first part is very simple. So R will be the radius of that nucleus. It will be R naught a to the power 1 by 3. Okay. R naught is given 1.2 in femtometer, right? So 1.2 into.
Sir, in meter.
Sorry.
R naught in meter given है ना?
So you can write. So it is given in this meter. So what is from here you can clearly write that it will be, since 10 to the power 15 meter means femtometer, on 10 to the power minus 15 meter means 1 femtometer. So from here you can clearly write it will be 1.2 femtometer. You can write in meter also, that's not a problem. Okay. So then that mass number for this is 56. So its power will be how much? 1 by 3. And that unit obviously it will be in femtometer. Okay. So if you calculate it, so you will basically get how much?
4.59.
Very good. 4.59 femtometer. Also, you can write it in your meter also, since you are interested. So you can write like 4.59 into 10 to the power minus 15 meter. Okay.
Yes, sir.
Good. Very good.
Sir, 55.85 you have taken as 56, right?
Sorry. No. You see,
Uh,
your
P value.
A is mass number.
Oh, okay.
So mass number is 56. Okay. So radius of a nucleus always varies with mass number. Please note that this is mass number. It's not any value. So always used to take mass number. Mass number means number of proton plus number of neutrons present inside that nucleus. Okay. Second part is also very simple. So it's a volume. Since it's spherical, so 4 by 3 pi r cube. And r you already have calculated. Okay. So it will be 4 by 3 pi, you know, that is 3.14, and r is how much? So it will be 4.14 0.59 into 10 की power minus 15 meter. So it will be, of course, it will be cube. Okay. So if you calculate this number, how much you will get?
405.06.
Very good. So it will be approximately 405 into 10 की power minus 45 meter cube. Is it clear?
Yes, sir.
Very good. Shall I erase that left hand part? क्लास में सबको समझ में आ रहा है? बेसिक बहुत सिंपल प्रॉब्लम है, बट हमको करना है ना, क्योंकि एग्जाम में यहाँ से क्वेश्चन आता है. बहुत सिंपल है ये. आई थिंक हम लोग 12 क्लास में भी इस तरह की प्रॉब्लम किए हैं, है ना. बट क्वेश्चन में आपका एग्जाम में आता है, नेट गेट जेस्ट जैम सब में आता है ना.
Sir,
यस.
how did you convert that R not from meter to centimeter?
No, see, 10 की पावर minus 15 meter equals to 1 femtometer.
Oh, okay, sir.
Okay. Shall I erase left hand part? Shall I erase?
Yes, sir.
Yes, sir.
क्लास में सबको समझ में आ रहा है या नहीं?
Yes, sir.
Okay. So how will do that C part?
Mass by what?
Okay, C part means mass density. Okay, let us write that symbol rho. Rho is mass density. So total mass divided by volume, and total mass already given, right? Total mass is how much?
55.85.
Very good. So rho equals to m by v, and m is given 55.85. Okay, in atomic mass unit. So I'll convert it into kg. Okay, so how will convert it? So
1.67 का मल्टीप्लाई करके into 10 की पावर
Very good.
minus 27.
very good. So it will be, if you multiply this by this factor, so automatically it will be converted into kg. So 55.85 atomic mass unit. If you multiply with this number by 1.66 into 10 to the power minus 27, so that unit will automatically be converted into kg. And you already have calculated that volume. So okay, so that volume was approximately 405 into 10 ki power minus 45. Okay, so obviously since that unit is meter cube, and that number meter cube means it is SI unit, and obviously that mass is in kg, so both are in SI unit. So you will basically that number that density will get in kg per meter cube. Okay, so if you calculate it, anyone calculate it?
2.303 into 10 to the power 17.
Very good.
Yes, sir.
kg per meter cube.
Into 10 की power 17 kg per meter cube. Okay. Okay. So if you have completed this part, then we can proceed for the next part. So now I am interested to describe you nuclear terminology. So that heading will be
एक्सक्यूज मी सर.
yes.
सर जो ये सेकंड पार्ट किया जिसमें हमने वॉल्यूम निकाला है,
Yes.
आर हमारा इक्वल है आर नॉट ए रेज़ टू पावर 1 by क्यूब.
Yes.
ये आर की वैल्यू हमारी आई थी 4.59 fm.
Hmm.
तो जब हम इसे आर क्यूब लिखेंगे तो ए की पावर 1 नहीं होगी सर, तो ए से भी मल्टीप्लाई होगा ना ये.
See, actually R we already have calculated, right, in a part.
यस सर, बट अगर हम इसमें आर पुट करते हैं तो आर नॉट ए 1 by 3 आएगा अगर हम किसी और क्वेश्चन में अगर इसे करते हैं.
Exactly.
जिसमें हमने पहले
तो R नॉट एक ही और
आर नॉट
हाँ एक्चुअली आप जो बोल रहे हो ना कि R इक्वल्स टू R नॉट ए टू द पावर 1 by 3 आपको कल सब्स्टिट्यूट करना था ना, बट हम लोगों ने ऑलरेडी ये सब्स्टिट्यूट कर. यस.
अब सर इसमें हमने आर क्यूब निकाला है तो आर नॉट क्यूब होगा तो ए इंटू ए नहीं होगा फिर.
नहीं, एक्चुअली देखो ये जो R है हम लोगों ने पार्ट ए में कैलकुलेट कर लिया. आप ये बोलना चाह रही हो कि R की जगह पे आप ए लिखो, है ना, R नॉट ए की पावर 1 by 3 ए लिखने के लिए बोल रहे हो आप? ऐसे बोल रहे हो? आर यू आस्किंग लाइक दिस?
यस सर.
हाँ, but see this R we already have Yes, you
अगर
can.
सर हम इसको अकॉर्डिंग कैलकुलेट करते हैं तब हमारी जो वैल्यू आ रही है ना 405 इंटू 10⁻⁻45 तब आ रही है। अगर हम जनरली सिर्फ आर की वैल्यू पुट कर रहे हैं तब हमारी वैल्यू आ रही है 324.54 इंटू 10⁻⁻45।
नहीं, you are making mistake, I think.
मैंने 2 बार कैलकुलेट कर लिया।
अच्छा, आपने 2 बार कैलकुलेट किए हो?
सर मुझे डाउट था इसलिए मैंने
नो 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 नो, डाउट नहीं होगा इसका। क्यूब करो। आई थिंक यू आर मेकिंग मिस्टेक समवेयर हियर। हाँ,
79.507
ये
क्यूब का
कितना आ रहा है इसका?
79.507।
हाँ ठीक है, इसके साथ 3.14 का मल्टीप्लाई करो।
कंप्लीट कर लिया 324.54। तीनों
ओके,
का आपस में 1।
हाँ तो फिर इसका 4/3 का मल्टीप्लाई करो 324 के साथ। 4/3 का कितना होगा?
4/3 इंटू 3.14 और ये 79.507 तीनों का कंप्लीट 324 आ रहा है 0.54।
नहीं, ऐसा तो नहीं है। पुनीत, have you checked done this?
Yes, sir.
No. I think you are making mistake. You please check that your calculation. I think you are making mistake because we are doing the same thing. Whatever you are doing now, r equals to r naught into
405 ही आ रहा है सर।
हाँ 405 ही आएंगे। I think you are making mistake because
405 ही आ रहा है।
हाँ
ही आ रहा है सर।
yes. I have already checked that you are making mistake somewhere because yes. Your voice is not clear. You please check in your home, okay? So I think you are making mistake somewhere, okay? You will get exactly same number, and it's a very simple problem. I think there should not be any confusion here. Some silly mistake you are doing. You please check at your home, okay? I think we will get this same number.
I think उन्होंने क्यूब नहीं किया।
हाँ, maybe. Please check. Very simple question. Okay. Now that heading will be. You please check if you have any problem. Na, you can ask me. After class, because we have to optimize that class. You know, because you have to finish the syllabus. If you have any question, you can ask me anytime. Like Puneet used to ask me. Okay, anytime you can ask me. Okay. So next heading will be nuclear terminology. Okay. So first we will discuss about that isotope. You people already knows about this. So first we will discuss isotope. So what is isotope? So
The
please
same atomic number but different mass number.
please write the definition. Yes, nuclei with same atomic number but different mass number are called isotopes. Nuclei.
Repeat again.
Yes. Nuclei with same atomic number but different mass number are called isotopes. So example, if people know like hydrogen isotopes, so they will have same atomic number but they will have different mass number. So see, these are the isotopes of hydrogen. If people know, these are the atomic number. So they have same atomic number but different mass number. Okay. Next, please write isotone. So isotones, please write the definition. Nuclei with same neutron number, are called isotones. Example, carbon same nuclei with same neutron number. Neutron number means number of neutrons. Same neutron number are called isotone. For example, carbon 6, 13, nitrogen 7, 14. You see here, number of proton is how much? 6. Mass number is how much? 13. So neutron number will be how much? A minus J. 13 minus 6, 7. Here also you see, mass number is 14. Atomic number is 7. So neutron number will be 14 minus 7. That will be 7. So they will have same number of neutrons. So they are basically isotones. Next, isobars. Isobars. Okay, so please write the definition. Nuclei with same mass number but different atomic number are called isotones. Okay, for example, yes,
The different what? Atomic number.
Different atomic number. For example, so nuclei with same mass number but different atomic number are called isobars. Okay, for example, suppose you have oxygen 8, 16, nitrogen 7, 16. You see, they have different atomic number, but they have same mass number. So they are basically isobars. Okay. Next definition is number 4, mirror nuclei. Okay, please write the definition. A pair of isobaric nuclei where in the nucleus,
Can you repeat it?
yes, a pair of isobaric nuclei where in the nucleus proton number and neutron number are interchanged. A pair of isobaric nuclei where in the nucleus proton number and neutron number are interchanged. For example, carbon 6, 11, boron 5, 11. So you see isobaric pair of isobaric nuclei. So they will have same mass number, but its number of proton will be same as its number of neutron. So here number of proton is how much? 6. Its number of neutron will be how much? 11 minus 5, 6. So the proton number of this nuclei will be exactly same as the neutron number of this nuclei, and proton number of this nuclei will be exactly same as neutron number of this nuclei. You can check. Proton number is how much? 5 for boron. You can check that number of neutron, that will be 11 minus 6, that will be 5. So proton number and neutron number are interchanged. Okay.
Yes, sir.
Shall I proceed? So it's a basic terminology. You people, I think you people know about this. Okay. Now we'll proceed about that mass of nucleus. Okay. So nuclear mass. So this is the symbol of your nucleus, any nucleus. So that yesterday we have defined that mass MP means mass of a nucleus, the mass of a proton, single proton, and Mn is the mass of a single neutron. So here that number of proton is Z, A minus Z number of neutron is there. Then mass of nucleus will be how much? And let us give that notation, capital M NuC. It means mass of nucleus. It will be how much? So you have here inside nucleus you have Z number of proton, A minus Z number of neutron. each proton has mass mp, small mp, and its neutron has mass small mn. So how that mass will be how much? Mass of nucleus will be
MP plus
MP plus Mn.
A minus z
minus Z Mn.
mn. So this you are expecting actually, but the mass of actual mass of nucleus will always be less than this value, and there will be some factor that is delta m.
Binding energy.
Okay, so delta m is known as, so what I'm saying, the actual mass of a nucleus is always less than the sum of the mass of the proton and sum of the mass of the neutron, and there will be some factor that is delta m. So delta m is the reduced factor. Delta m is known as mass defect, right? Mass defect. समझ में आया सबको? So जो actual mass होगा always less than some factor, then that is delta m. Delta m is known as mass defect. So you can write this equation in terms of binding energy also. So mass of nucleus will be how much? Zmp plus A minus Z Mn minus delta E by C square. Because the binding delta E here, what? Delta E means binding energy. And binding energy is nothing but delta M mass defect times C square. So from here you can write delta M equals to delta E by C square. So this is the actual mass of your nucleus. Okay. So let us solve on problem based on mass defect. Okay. Shall I erase?
Yes. Yes, sir.
Yes. Any question? Okay. So for gold nuclei, you have gold nucleus. So atomic number is how much?
79.
Very good. 79. Mass number is 197. For gold nucleus, that actual mass is given. Actual mass means NuC, and that is given as 196.966 U. Okay, and mass of a proton is given as 1.00727 U. U means atomic mass unit, and mass of a neutron Mn is given as 1.00866 U. So calculate the mass defect of gold nucleus. So actual mass is given, mass of a proton is given, mass of a neutron is given. So you have to calculate the mass defect for this nucleus, gold nucleus. Can you calculate? And you have to, yes, of course, you have to calculate that mass defect in first in atomic mass unit, then in kg, as well as you have to calculate it in MeV per C square. So 3 units you have to calculate. So I'm repeating again, for this nucleus, the actual mass is given. Also, they have provided that mass of proton and mass of a neutron in terms of, in the unit of atomic mass unit. They ask to calculate that mass defect for this nucleus in terms of atomic mass unit, in terms of kg, or in the unit of MeV per C square. Okay.
At 1.63021 U.
1.63, very good. 1.63 you are getting, right? Okay.
Yes, sir.
So shall I erase? So mass defect means what? So mass defect delta M is nothing but Z times MP plus A minus Z times Mn minus actual mass. Actual mass means MNuC. Okay. So Z is how much? 79 into mass of a proton is given as 1.00727 in atomic mass unit. Then A minus Z will be how much? on 8, right?
Oh, okay.
Very good. Mass of a neutron is how much? 1.00866 U. Then last factor is actual mass, and it is how much? 196.966 U. So if you calculate it, it's a very simple mathematics. So you will get approximately 1.6 in atomic mass unit. Okay. किसी को कोई डाउट है इसमें? So first you got this mass defect of this nucleus in atomic mass unit, and that value is 1.63. So to calculate it in kg, you have to multiply by 1.66 into 10 to the power minus 27. So if you calculate it, how much you will get?
2.6144 into 10 to power minus 27.
Anyone else? How much you are getting?
2.7 into 10 to the power minus
2.72 into 10 to the power minus
10 to the
Very
power
good,
minus.
very good, very good. Everybody got answer. So it will be 0.27 into 10 to the power minus 26, right? Kg.
Sir, can you write it above?
Yes, sir. So if you calculate it in kg, you will get 0.27 into 10 to the power minus 26 in kg. Okay. Sorry, your voice is not clear.
सर ये कन्वर्जन यूनिट ए से केजी ये सब गिवन होगा कि याद करना पड़ेगा?
आपको सिर्फ एक ही कन्वर्जन याद करना पड़ेगा, दैट इज ऑन एटॉमिक मास यूनिट टू सॉरी दो, एक आपका ऑन एटॉमिक मास टू केजी कैसे करना पड़ेगा, और दूसरा आपका ऑन एटॉमिक मास इक्वल्स टू 931.5 mV/s. दोनों आपको याद करना पड़ेगा, बाकी कुछ नहीं, बाकी सारे प्रोवाइडेड होगा. ठीक है, और याद नहीं करोगे तब भी चल जाएगा, आपको जस्ट ऑन एटॉमिक मास यूनिट का डेफिनेशन से सारी चीज आ जाता है ना, वो बैकग्राउंड आपके पास है तो सारे चीज आ जाएंगे, है ना. बट उसमें टाइम कंज्यूमिंग है, आपको एक कॉम्पिटिटिव एग्जाम में कुछ तो याद करना पड़ेगा, उसके लिए कुछ नहीं कर सकते हो. बट अगर आपको डर है तो वहां से निकल सकते हो, क्योंकि हम लोगों ने कल वहीं से स्टार्ट किया था, बेसिक डेफिनेशन से कैसे हम लोगों ने सारी चीज हमको मिला था, है ना. तो सारी चीजें ऐसे आप सोचोगे तो फिर प्रॉब्लम हो जाएगा. अब कुछ सोचो मत, अगर भूल गए तो आप निकाल सकते हो, क्योंकि सारे प्रोसेस आपको मैंने बता दिया है ना, कि कैसे सारी चीज आया है. ठीक है ना.
Sir, 1520 mV/s².
1520.
20.
Yes, around
1518.54.
Yes, 1518, right?
Yes, sir.
So it will be on 518 around. So since you got this delta M in atomic mass unit, it was how much? On 0.63 in U. So if you want to convert it into MeV/s², yesterday we have derived these things, so you have to multiply.
931.5.
Very good. MeV/s². Okay, so you will get approximately on 518 MeV/s². Okay. समझ में आ रहा है क्लास में?
Yes, sir. Yes.
Yes, sir.
Okay. Shall I erase?
Yes, sir.
Sorry? Can you please repeat? Okay. Next we will discuss that nuclear angular momentum. आवाज कभी आवाज क्लियर नहीं आ रहा है, अगर किसी को पूछना है, कोई छूट जा रहा है ना, यू कैन आस्क मी आल्सो ऑन व्हाट्सएप आल्सो ग्रुप. ओके. कभी कभी क्या है ना, आपका आवाज नहीं आ रहा है, बट हमको क्लास को ऑप्टिमाइज करना पड़ेगा ना, है ना। चलो, न्यूक्लियर एंगुलर मोमेंटम, इसमें क्या है, सपोज यू हैव सम न्यूक्लियस, सो इनसाइड न्यूक्लियस यू हैव प्रोटॉन and neutron. So each proton and neutron can have two type of motion. So before going to this, now we'll discuss about that nuclear angular momentum, then nuclear magnetic moment we'll discuss, okay, then quadrupole moment we'll discuss, then we'll discuss about that nuclear parity, how they are actually originating inside that nucleus. But all these things, nuclear angular momentum, nuclear magnetic moment, quadrupole moment, and parity, these things will calculate for different nuclei by using सेल मॉडल. तो यहाँ जस्ट हम डिस्कस करेंगे कैसे ये सारे प्रॉपर्टीज ओरिजिनेट हो रहा है ना. बाकी सारे जो प्रॉपर्टीज है डिफरेंट न्यूक्लियाई के लिए हम सेल मॉडल के यूज करके हम कैलकुलेट करेंगे. तो इनसाइड न्यूक्लियस you will have proton and neutron. Each proton can have orbital motion. So orbital motion will give you orbital angular momentum.
Orbital motion is only for proton.
No. Each proton and each neutron, or you can say in other words, each nucleon will have orbital angular momentum, orbital motion. Okay. Then it can have spin motion also. Each nucleon, so it can have spin motion also.
Sir, it
Yes.
means proton and neutron both will have this.
each nucleon means न्यूक्लियस के अंदर जितना सारे न्यूक्लियन है, जितना सारे प्रोटॉन्स है, जितना सारे न्यूट्रॉन्स है, सारे का ऑर्बिटल मोशन है ना.
ओके सर.
उसके लिए आपको क्या मिलेगा, एक आपका ऑर्बिटल एंगुलर मोमेंटम मिलेगा. हर एक का स्पिन भी है, स्पिन के कारण क्या मिलेगा, स्पिन एंगुलर मोमेंटम. Okay. So each nucleons will have orbital motion. Orbital motion will provide you orbital angular momentum. And also each nucleons will have some spin, and spin will provide you the spin angular momentum. So orbital angular momentum or orbital motion is characterized by orbital quantum number. Sorry. Orbital quantum number, and that is basically denoted by small l, and orbital quantum number can take these values, discrete values, 1, 2, 3, so on. Okay, that you people know. So L corresponds to 0 will give you s orbital, 1 will give you p orbital, 2 will give you d orbital, 3 will give you f orbital, and so on. Okay.
Yes, sir.
Now the magnitude of, so this is your quantum number. So magnitude of orbital angular momentum will be how much? So magnitude of orbital angular momentum that will be basically denoted by small l vector, its magnitude, and you people know that from quantum mechanics that will be L into L plus 1 h cross, where L is the quantum number, orbital quantum number. Okay. So for different nucleon, you can easily calculate from this equation magnitude of orbital angular momentum. So here L is orbital quantum number. Okay.
Yes, sir.
Yes. Similarly, spin of each nucleon is how much? Or spin quantum number of each nucleon is how much?
Half.
Spin quantum number. Let us write notation. Spin q dot no means quantum number, and you know that is how much? Simply half. So for each nucleon, that spin quantum number is half. So half means they are basically fermions. So like electron, protons and neutrons, also they are fermions. Okay, since their spin is half.
So plus minus half.
No, spin. This is quantum number. You are making mistakes. So this quantum number is half. Okay. So when we'll take that angular momentum, that can be some plus minus s into s plus on h cross square. Okay. But
Yes,
here I am taking only that quantum number, like that orbital quantum number. I have not used that plus minus. That number was 0, 1, 2, 3. Okay. Did you get? Shall I repeat?
yes, sir.
I have to repeat, or you got answered?
Yes, sir, understood.
Okay. So that magnitude of spin angular momentum will be how much? Basically, s into s plus on h cross, and you know that s, right? S is how much? S is quantum spin quantum number that you know. So it will be basically, if you substitute this value, half into 3/2 h cross. So it will be simply √3/2 h cross. Okay. तो आपका स्पिन क्वांटम नंबर का एंगुलर मोमेंटम आ गया, और ऑर्बिटल का, ये आप लोग क्वांटम मैकेनिक्स में पढ़े हो, बेसिक चीज है. अब टोटल जो एंगुलर मोमेंटम है वो एक न्यूक्लियस है, उसका टोटल एंगुलर मोमेंटम मैं लिखना चाह रहा हूँ. आई एम टू राइट दैट एंगुलर मोमेंटम ऑफ न्यूक्लियस.
सर
यस.
तो स्पिन क्वांटम नंबर जो है लास्ट में क्या रिजल्ट आ रहा है?
हाँ, √3/2 h cross, because inside you have, inside square root you have half into 3/2, that will give you √3/4, and its square root that will provide you √3/2, and h cross is outside that square.
ओके सर, ओके. एक्चुअली दिखाई नहीं देता, इस वजह से
ओके,
बोला सर.
आपने लिख लिया?
यस सर.
ओके, वेरी गुड. Shall I erase?
Yes.
Now total angular momentum of nucleus will be how much?
S plus J. Sorry,
दोनों का
L
वेक्टर
plus
सम.
S.
Very good.
और सर
Total angular momentum of nucleus. Total angular momentum.
L vector plus S vector.
Momentum of a nucleus let us write that symbol, that is capital I. So I'm writing that angular momentum. So it will be basically sum for all nucleons. So each nucleon will have angular momentum. So you have to sum that. And let us give that notation Ln. So vector sum of orbital angular momentum of each nucleon. N means nucleon. So how many nucleons we have? You have to sum, give that vector sum, or you have to take that vector sum of angular momentum. Then you have spin part. So this is all about your total angular momentum of a nucleus. So if you take its magnitude, it will be how much? Simply I into I plus on H cross.
यस सर.
यहाँ पे ये I क्या है?
I
टोटल एंगुलर मोमेंटम क्वांटम नंबर.
Yes, total angular momentum quantum number है.
और सर ये कैसे कैलकुलेट होगा?
ये आपका हर, इसीलिए तो मैं बोल रहा हूँ ना, यहाँ जस्ट मैं क्या करूँगा, जस्ट ऑरिजिन के कहाँ से हो रहे करूँगा. ये सारे जो कैलकुलेशन है हम सेल मॉडल में हर एक न्यूक्लियाई, जैसे ऑड इवन सारे न्यूक्लियाई के लिए हम कैलकुलेट करेंगे, पूरा कैलकुलेट करेंगे. ओके, ठीक है, सेल मॉडल में, है ना. That will be interesting part. Actually आप देखोगे क्वेश्चन में आपका आइदर मैग्नेटिक मोमेंट निकालने के लिए बोलते हैं न्यूक्लियस का, कोई गिवन न्यूक्लियस का, या उसका स्पिन निकालने के लिए बोलते हैं, या उसका पैरिटी है ना, स्पिन पैरिटी दोनों एक साथ निकालने के लिए बोलते हैं, क्वाड्रोपोल निकालने के लिए बोलते हैं। वो सेल मॉडल का पूरा एप्लीकेशन है। विल डिस्कस डिटेल्स अबाउट दिस। ओके, जस्ट इसीलिए मैंने पहले आपको बोला था जो एंगुलर मोमेंटम, मैग्नेटिक मोमेंट कैसे न्यूक्लियस में ओरिजिन होते हैं वो हम डिस्कस करेंगे, बाकी सेल मॉडल में डिस्कस करेंगे। ठीक है, सो नाउ विल प्रोसीड फॉर न्यूक्लियर मैग्नेटिक मोमेंट। nuclear magnetic moment. So nuclear magnetic moment क्यों generate होता है ना? So first due to the orbital motion of proton. So you know, if suppose this proton is revolving around some orbit, okay, so since the proton is charged particle, so its motion will give some current. So since it is revolving, so it will make closed loop, and we know if there is a closed loop, it's carrying current I, so it will make some magnetic moment, and that you know that is nothing but mu equals to how much? I into A. You people learn this right in basic EM electromagnetic theory, right?
Yes, sir.
Since that proton is revolving around that orbit, the proton is charged particle, so it will produce some current, and since it is moving in a loop, so that loop will have some magnetic moment, and that magnetic moment is nothing but the current in the loop multiplied by its area. A means the area of that loop. So first reason for nuclear magnetic, yes.
Sir, inside the nucleus, proton is revolving.
Yes.
Okay, sir.
Inside the protons is revolving, neutrons is revolving, and during that rotation or orbital motion, they are spinning also. Okay, but please keep in mind that orbital motion of neutrons will not produce any magnetic moment because neutron is neutral. Particle. So it will, we don't have any, it will not carry any current, so obviously magnetic moment will be zero. So first reason is the orbital motion of proton. P means proton. Okay. Second reason, spin of proton and neutron. So spinning of proton and neutron will provide you that magnetic moment, or it will contribute to production of magnetic moment. How? So during that orbital motion of proton, it will spin also, right? During orbital motion, it will also make spin. So suppose you have a proton. Suppose this is your point particle. So everywhere inside that proton, it will have some charge, right? So when it will spin about its center of mass. So each point inside that proton will have some current, and each point is rotating or spinning about its center mass. So it means each point will have some current. So there will be many loop inside that, or many current loop inside that proton. So due to that infinite number of current loop inside that proton during its spinning, it will also contribute for magnetic moment. Is it clear what I'm saying? So आपका suppose,
sir, can you repeat once more, sir?
हाँ, जैसे आपका एक प्रोटॉन है, पॉइंट चार्ज है, तो उसका अंदर हर पॉइंट में क्या है आपका चार्ज है ना, चार्ज इज डिस्ट्रीब्यूटेड.
Yes, sir.
And each point when it is spinning, so कोई पे चार्ज है वो अगर रोटेट कर रहा है तो क्या उसमें करंट है ना. Actually current is, there is a current, so each point will carry some current and it is actually spinning, so it will make some closed loop. So that closed loop, each closed loop will give some current, magnetic moment due to the current. So there will be many number of loop inside that proton during its spinning. So it is like that. Suppose this is your proton, it is spinning about its center of mass. It will have many number of loop, current loop inside this proton, and that will give you the contribution of magnetic moment of nucleus. Is it clear? So during spinning of proton, it will produce magnetic. Repeat करना है? Sorry, your voice is not clear.
Yes, sir.
Repeat करना है?
Sir, it means proton will provide
Sir,
magnetic moment due to orbital motion and due to spin of its motion.
Exactly.
Okay,
So
sir.
during orbital motion, it will produce magnetic moment. During spinning also, it will contribute for magnetic moment. Is it clear?
Yes, sir.
Anyone asking question?
Sir. Yes, sir. Sir, how neutron is contributing the current carrying?
Yes. That I am going to discuss. So you know that neutron has proton का clear है, spinning का जो कैसे contribute कर रहा है magnetic.
Yes.
सबको clear है? कोई question? Sorry, his voice is not clear. Can you please repeat? Can you please repeat? Extremely sorry, voice is not. Extremely sorry.
रिपीट करने को बोल रही है.
Repeat करने
चैट में लिखने के लिए बोल रही हूं.
Okay.
चैट.
हाँ. Actually repeat करने के लिए बोल रहे हैं शायद, है ना? मैं repeat कर रहा हूँ. Suppose मान लो आपका proton है. So it has charge, right? So it is spinning about its center of mass. So spinning is like that. So inside proton, each point will have charge, right? And each point is actually rotating or spinning. So each point will make some current loop, and there will be many number of current loop inside your proton during its spinning. So each point में अगर आपका current, each point आपका current loop बना रहा है ना, उसमें current है, तो हर loop का there will be many number of loop, current loop, and each loop will contribute some magnetic moment because it is carrying current. समझ रहे हो ना कि हर पॉइंट में आपका कुछ चार्ज होगा, वो जब स्पिन करेगा तो वो उसका रोटेशन होगा लाइक अ क्लोज लूप, एंड इट विल प्रोड्यूस करंट, एंड सिंस इट इज अ क्लोज लूप so it will have some magnetic moment. So there will be many number of current loop and it will contribute for magnetic moment during its spinning. Is it clear?
Yes, sir.
Okay. Now someone has asked a really good question. What about that neutron? How it is contributing? So you know that question, although I have to use some particle physics, but I am extremely sorry. Those who do not know that neutron has some internal structure. So if you see that neutron has internal structure, it's actually made up of, neutron is not a fundamental particle, it's made up of 3 quark. Okay, so it made up of 3 quark, and that quark has some charge, right? Fractional charge. Like up quark has fractional charge is 2/3 times the electronic charge, down has -1/3 times that electronic charge. So in simple way, for the to understand you, I am giving some explanation. So suppose this is your neutron and it is spinning. So its center will have some positive kind of charge. So inside neutron will have some different charge. So during its spinning, the inner core, you can say, the inner core will have some positive charge, and its spinning will give you some magnetic moment. Then in the middle part, you will have some minus charge, and its spinning will give some other magnetic moment, and the outer part you will have some positive charge, and its spinning will give you some magnetic moment. So if you sum all this magnetic moment, you will get some non-zero values. So due to the inner structure of neutron, it will, although its net charge is 0, but it's due to its inner charge, or you can say it's made up of 3 quark, and it has a different charge. Due to this different charge configuration, the inner part will have charge like positive, at the middle it will have charge negative, and at the outer core, outer part, you can say it is positive charge. So each part during its spinning will give or contribute some magnetic moment. So if you sum all this magnetic moment, definitely you will get some non-zero values. Okay, so this is all about the spinning of proton will contribute magnetic moment, spinning of neutron will contribute magnetic moment, orbital motion of proton will contribute magnetic moment, but orbital motion of neutron will not contribute any magnetic moment. Third is exchange current. Third is exchange current. So you know that from that basic of nuclear physics, I'll discuss this about nuclear force. So there is always interaction between proton and neutron, or you can say in other words that nucleons. Nucleons are interacting to each other by the exchange of pi mesons. So when the proton is interacting with the neutron, it will emit pi plus. Pi plus means pion particle having positive charge. So proton can interact with neutron by the emission of pi plus, and similarly neutron can interact with proton by the emission of pi minus. Pi means pi meson. We'll discuss these things in nuclear force also, as well as we'll discuss in particle physics. The proton can interact with neutron by the emission of pi plus, and neutron can interact with proton by the emission of pi minus. So since it emitting charge particle, so charge particle when it is emitting, it will definitely have some current. So it's in pictorial form. If you write it, that proton will be interacting with neutron by the emission of pi plus. Since pi plus has positive charge, so it will carry some current also because it has charge. And of course, neutron, when it will interact with proton, it will emit some pi minus. So that pi plus and pi minus, that exchange of pi plus and pi minus, since they are charged particle, so their emission also contribute some magnetic moment. So three reasons for nuclear magnetic moment. First, orbital motion of proton will contribute. Then you have spinning of proton and neutron, both will contribute. Then exchange particle, and that exchange particle is obvious in nuclear force. That exchange particle is pi mesons. So when proton will interact with neutron, obviously it will emit pi plus. When neutron will interact with proton, it will emit pi minus. And since they are charged particle, so their emission will produce some current, and that current will give some contribution of magnetic moment. Is it clear?
Yes, sir.
Yes.
Yes, sir.
Okay. How much is the time? Okay,
It's
time is over. So today we have to stop here. So from tomorrow we'll discuss. Okay, we'll discuss that magnetic moment, some few more part. Then we have to go to quadrupole moment, then parity. Then we'll go to that important part, that is binding energy. Okay.
Sir,
Okay.
Yes.
Thank you, sir.
sir,
Okay.
magnetic moment on nucleus is 0.
No, magnetic moment is not 0. Dipole moment is 0. Magnetic moment. That's why from the beginning I'm telling
Sir,
you.
on nucleus.
No, magnetic moment is not always 0. It depends upon that your number of neutron and number of proton. If it is even, then obviously it will be 0. Even means number of proton and number of neutron both are even, then it will be 0. But if the mass number is odd, there will be some contribution. We'll discuss in cell model. Please have a patience, because it's actually important part. So everything we'll discuss, we'll calculate in cell model. Okay. And you can say that dipole moment will be 0. That will calculate tomorrow. Okay. You have more question? You have any more?
No, sir. No, sir.
Okay, we have to stop. Okay. Okay. Bye, all.
Thank you, sir.
Thank you, sir.